Your AI feature costs 3 times what your CFO approved. Not because your vendor lied about token pricing, because your vendor told you the truth, and you only read the first line. You budgeted for 1 inference call per user request. You are running 3. That is not a technical footnote. That is a structural billing hole in your unit economics. And if you have not done this math yet, you are already behind. Here is what actually happens when a user submits a prompt to your enterprise AI system. Call 1. Input validation. Before your primary model sees a single token, a guardrail layer scans the input. It checks for prompt injection, PII leakage, policy violations, jailbreak patterns. This is not optional if you are operating in a regulated industry. This is not a feature. This is the floor. That scan is a full inference call. It costs money. It adds latency. Call 2, your primary model. This is the call you budgeted for. This is the only cost your engineering team put in the spreadsheet. Call 3, output validation. Before your system returns a response to the user, a second guardrail layer intercepts the output. It checks for hallucinations, confidential data exposure, regulatory non-compliance, toxicity. Another full inference call. Another line item that does not appear in your vendor's pricing page. 1 user request, 3 model calls. Your per request cost is not what you think it is. Let me give you the arithmetic. Assume you are running a mid-tier deployment on a frontier model. Input cost, approximately $3 per million tokens. Output cost, approximately $15 per million tokens. Your primary call, let us say 800 input tokens, 400 output tokens. Cost per call, roughly $0.0084. Now add your input guardrail. The validation prompt itself runs 300 to 600 tokens through a secondary model. If you are using a dedicated safety classifier, NEMO guardrails, a custom fine-tune, or an API-wrapped evaluator, that is another $0.002 to $0.005 per call. Now add your output guardrail. Similar compute load, similar cost range. Total per request cost, $0.012 to $0.018 versus your budgeted $0.0084. That is a 43% to 114% cost overrun per request at scale. At 1 million daily active requests, you are looking at $4,000 to $10,000 in unplanned daily spend. Monthly, $120,000 to $300,000. Annual, up to $3.6 million. That number was not in your board deck. Now here is where the decision gets harder. Some teams respond to this math by cutting corners on the guardrail layer. They skip the input validator. They run a lightweight output filter. They tell themselves the primary model is safe enough. That is a risk transfer decision, not a cost savings decision. The question is not whether you can afford the guardrail overhead. The question is whether you can afford what happens without it. In 2023, a major European financial services firm deployed a customer-facing LLM without a structured output validation layer. The model hallucinated account balance data in 0.3% of responses. 0.3% sounds negligible. At 500,000 daily queries, that is 1,500 incorrect financial disclosures per day. The regulatory exposure from 6 weeks of operation exceeded the cost of running a full guardrail stack for 4 years. The guardrail overhead is not a cost problem. The guardrail overhead is a pricing problem. If your margins cannot absorb a 3x inference multiplier, your AI feature is not yet a viable product. Let us go deeper into the architecture, because the cost structure changes depending on how you build this. There are 3 common deployment patterns for enterprise guardrails. Pattern 1. Third-party API wrapper. You route your prompts through a managed safety API before and after your primary model call. Examples: Guardrail's AI, LlamaGuard via API, or AWS Bedrock Guardrails. Cost structure: predictable, per-call pricing, but you are now dependent on a third party's uptime and latency SLA. Every millisecond that service adds to your round trip is visible to your end users. Latency overhead in this pattern typically runs 200 to 800 milliseconds per request. At consumer-grade patience thresholds, which research places at under 1 second for interactive AI, you have a UX problem before you have a cost problem. Pattern 2. Co-deployed validation model. You run a smaller, faster safety model in your own infrastructure alongside your primary model. Nemo Guardrails is the most common enterprise implementation. Cost structure: fixed infrastructure overhead, lower marginal cost per call, but your DevOps team is now maintaining 2 model deployments. This pattern makes sense at high request volume. The break-even point against API-based guardrails typically occurs around 800,000 to 1.2 million monthly requests, depending on your cloud provider and instance types. Below that threshold, co-deployment is more expensive than the third-party wrapper. Pattern 3. Prompt engineering as a guardrail substitute. Some teams attempt to collapse all 3 calls into one by embedding safety instructions directly into the primary model's system prompt. This reduces cost. It also reduces reliability by a margin that is not acceptable in regulated environments. Internal red team audits at multiple Fortune 500 deployments have shown that prompt-based guardrails fail under adversarial input conditions at rates between 12 and 31%, depending on model and instruction design. That is not a guardrail. That is a suggestion. The data does not support this as a production safety strategy. Architecture determines your cost floor. Cost floor determines your viable market. Now let us talk about the hidden cost that does not appear in any infrastructure audit: latency. Every guardrail call adds time. That time is not free. In B2B SaaS deployments, acceptable AI response latency benchmarks from Gartner's 2024 Enterprise UX Research sit at under 2 seconds for non-streaming responses. With a naive sequential guardrail architecture, input validation, then primary call, then output validation, you are chaining 3 inference operations. At P95 latency, that sequential chain can exceed 4 to 6 seconds on standard API infrastructure. The engineering fix is parallel execution where possible. You can run input validation concurrently with your primary model call, then apply output validation after. This collapses your latency from 3 sequential calls to roughly 1.5. But it requires engineering investment to implement correctly. That engineering cost is also not in your vendor's pricing page. Here's the decision framework this audit produces. If your gross margin per AI-assisted transaction is below 65%, a 3-call guardrail architecture will compress your unit economics to near 0 by the time you add infrastructure, DevOps, and support overhead. This is not a solvable problem with better prompt engineering. This is a product pricing problem that must be resolved before you scale. If your deployment handles sensitive data categories, PII, financial records, health information, legal documents, the 3-call architecture is not a cost decision. It is a compliance obligation. The cost of the guardrail overhead must be built into your product price from day one. If you priced your product before modeling this cost, you have a pricing problem, not an infrastructure problem. If your monthly request volume is below 500,000, third-party API guardrails are more cost-efficient than co-deployment. If your monthly request volume exceeds 1.2 million, co-deployment is the more defensible architecture. The range between those 2 numbers is where most mid-market SaaS companies are currently making this decision incorrectly, by defaulting to whichever pattern their founding engineer was most familiar with. The audit verdict. Enterprise AI without a structured guardrail layer is not a product. It is a liability with a user interface. The three-call architecture is not gold plating. It is the minimum viable compliance structure for any AI feature touching regulated data or consumer-facing output in North America or the EU. The cost is real. The cost is fixed. The cost is non-negotiable. Your job is not to eliminate it. Your job is to price your product so the math works before you scale. If it does not work at 1,000 users, it will not work at 100,000. Fix the unit economics now, or your growth curve becomes a liability curve. Subscribe to the Stack Anatomy. We'll see you in the next dissection.